Hello and welcome to this video on balancing chemical equations. I'm going to go through three equations starting with this one. I'll just remind you in a second of the rules for balancing chemical equations and give you a suggestion of how to go about doing it, and then I'll remind you that each time that you can pause the video if you want to, have a go at it yourself and then see my solution. Here we have calcium hydroxide, an alkali, reacting with hydrochloric acid to produce calcium chloride and water. It's a neutralization reaction. Now the small numbers refer to just the element in front of them, or if there's brackets, both the things in front of them. So this means we've got one calcium ion, it's actually Ca2+, but I'm not going to bother putting in the charges, and two hydroxide ions, and that means two oxygen atoms and two hydrogen. Here we've got just a hydrogen and a chloride in the hydrochloric acid. Here we've got one calcium, the two just refers to the chloride ions, so there's two of those, and here two hydrogens and an oxygen. Now this isn't currently balanced, as you can probably see now that it's written out like that. The only way to balance it is to add big numbers in front of the formulae, and those big numbers affect all the atoms in the formula. So pause now if you want to try this. Okay, so the first thing to notice is that the calciums are balanced, they're okay, but I've got two chlorides here and only one here. Now if I put a big 2 in front of my HCl, that means two hydrogens and two chlorides. Chlorides are now balanced, but I've got two hydrogens there as well, so that makes 4, only 2 here. Now if I put a 2 in front of my water, that means 2 times 2 hydrogens, because it's 2 water molecules and each one's got 2 hydrogens. But it also means 2 oxygens, and that's good news because I've got 2 oxygens over here, so that's now balanced. Moving on to this one, slightly harder one. This is a combustion reaction now, ethanol, C2H5OH, reacting with oxygen. So pause this now if you want to try it yourself. I'm going to go through the same process now of drawing out the number of atoms I've got. So there's 2 carbons, 5 hydrogens, an oxygen and another hydrogen. It's written like this because this hydrogen is attached to the oxygen instead of to the carbons. Just 2 oxygens in that oxygen molecule, a carbon and 2 oxygens from the carbon dioxide, and 2 hydrogens and an oxygen over here. Okay, so my carbons I'll start with, they're not balanced, so if I put a 2 here, that's 2 carbons and 2 more oxygens for my 2 CO2 molecules. Now I've now got 5 oxygens on this side and only 3 on this side. Now because my carbons are already balanced, I don't want to go putting any big numbers here, so I need to get some more oxygens over here. I've also got to balance my hydrogens though, so maybe I'll do that first. That might be simpler. I've got 6 hydrogens here and only 2 here, so a 3 there means that I've now got 3 times as many, so 3 times 2 is 6. And I've also got 3 times as many oxygens. That gives me a total of 7. Now to get 7 on this side, it would be good if I could have 6 here, so that's 3 times 2, 3 O2s is 6. And now that, if you add it all together, they all balance, so that's done. On to the third one, aluminium oxide. This would be an electrolysis reaction being broken down into aluminium and oxygen. Pause now if you want to give it a go. And I'll go through this. So we've got 2 aluminiums and 3 oxygens in aluminium oxide, just 1 aluminium there and 2 oxygens here. So obvious first thing to do is to double up the number of aluminiums, but now I've got to get this up to 3, and I can't put 1.5 really. Sometimes you do see equations balanced with half numbers, but generally you shouldn't. So what am I going to do? Well, what I could do is go back and I could double up this whole compound here. So that's twice as many aluminiums and twice as many oxygens, and now I can add a 3 in and I'll get 6 oxygens on each side, so that's good. But now my aluminiums aren't balanced. That's no problem. I can just go back and rub out that 2 and instead have 4 aluminiums, and now I've got a balanced equation.